So till now we have used the data sets and we have splitting the data sets in randomly. Okay, but the main problem is that sometimes random splitting is not better. So in such situations we have to use the better splitting time, that is time based splitting. So let's see what, where, and when we have to use this time based splitting concept. So let's see. So we have actually a data set. Suppose let's take, we have a data sets dn, and we have divided these data sets in 3 parts randomly. And suppose let's take parts is dtrain, and we have seen this thing already. Okay, these d cross validations, and the last part is d test part. Okay, and we have doing these jobs randomly. Okay, and in generally if you just see this random split, in these random split are doing in and 60% for training data, 20% for cross validations data, and 20% for test data. We have doing, typically we have used this partitions ratio. Okay, this means what? Actually this means if you just take, consider a data set. Suppose let's take, we have the data set like that. Suppose this is our dn, and now we are interested to find the 3 kind of data sets, that is train, cross validations, and test. Suppose this is the small chunk from this dn data set. Suppose let's take, it is our train data set, and it's our cross validation chunk of data set, and this is the, suppose let's take, this is the test chunk of data sets, and we have see this is 60% of whole data set, this is 20%, this is 20%. This means what? Actually if you just see this thing, this thing means what? Suppose if we pick a point, suppose from here, suppose let's take our, this point is xi. This means the probability of these points will lie on train data sets is 0.6. This probability of this point is lie on cross validation data sets is 0.2, and same for test data sets also. Because we have from the whole training data sets, we have taken the 60% is 60% data, and 20% for cross validation data, and 20% for test data. So since we have doing the randomly doing these jobs, so the chance, so the distributions of the data is equal probable for each chunk. Okay, so the actual probability, so of this data will be on train sets, this probability for train of our data xi is 0.6. Similarly, for probability of this data for cross validation set, this probability will be probability of cross validations is equals to xi is equals to 0.2, and similarly for our test data set also, probability of test data is equals to xi, its probability is also 0.2. I think you have understand this thing. Okay, so now let's start what is actually the time based splitting. Let's see what is actually the time based splitting. So this is depend on situations. We have not tell that a time based splitting is always better than and random splitting, but there are some cases where random split from random splitting, time based splitting is better, but this depend on situations or situations. So this is depend on a type of data sets. So let's see what kind of data sets and which kind of data sets time based splitting is better, and in which kind of data sets random splitting is better. So let's see first. Let's see this thing. So So if we have a data set such that in this data sets we have a timestamp, suppose let we have a data set like that. Suppose let we have pairs data sets like that. We have seen this kind of data sets also previously. Suppose let this is the type of data sets, and suppose if we consider the text review data sets, if we consider the text review data sets, actual whole text we have to find its polarity, means this data is actual positive or negative. This text review, our query text review is actually its polarity is actual positive or negative. We have to find the at the end of the day. Suppose let's take this is our actual features vector. Suppose let's take is our f1, f2, f3. This is our features vector fd, and here our review. Suppose we have n number of review in our collected data set. Suppose let's take we have n number of review in our collected data sets, and here the corresponding output, suppose its polarity will be positive or negative, these two types of, and suppose let's take here is our features vector that we call xi in general, and its original output yi. This we have see this thing, and if there have some kind of features, suppose let here we have some kind of features like that. We have collected the data is such like that we have also the timestamp of this data, means when the data actually collected, when the age review is actually collected for a product, we have collected this time also. Suppose for this time we have collected time I. This is the timestamp for age review. In such scenario we can from random splitting, our time based splitting is better. If for a data we have a timestamp, timestamp corresponding to age data, then from random splitting, time based splitting is always better. Okay, so in such cases a time based splitting, so in short everywhere I am calling TBS, don't be confused what is actual TBS means time based splitting is okay. I think you have understand this concept when we have used this thing. So now the thing is how to split this time based splitting. In random splitting, we have simply divided our data sets randomly as our requirement, 60% 20-20 or 70% 15-15 or 18-10-10 as our requirement. We can easily doing these jobs, but how we will split the data in the time based splitting? Suppose let's see such, let's draw the first our data sets. So understand the thing through the pictures. I think it will be better. Suppose let's take it's our data set, and in this data sets we have features vector, corresponding output vector, and corresponding timestamp also. Suppose let's take it's our review 1, review 2, review 3, up to review n, and here actually our polarity means here actually our output polarity, our polarity will plus or minus, and here actually we have timestamp, and here actual features vector f1, f2, F3, suppose let's take we have D, and suppose let's take it's our ith review, and ith review corresponding features vector xi transpose, let's take, and corresponding polarity yi, and its time corresponding, let's take its time is ei, let's take. So the partitions formula will be like that. So in first we have to do, we have to sorting this data. So our first job is we have to sort this data according to our time, from old to new. We have sorting this data from old to new, old time to new time, sorting this data. First we have to do in these jobs a time column according to a time column. So we are sorting for our whole data set, that is we call the whole data set is dn, the whole data is dn. Then we are sorting this data in ascending order, in ascending order for of time columns. Okay, I think we have to first doing these jobs, then we have to do the splitting. So then we have to do the splitting. So how? Suppose let's take, then first 60% of the data, first 60% of data we are taken as our training set. First 60% of data we are taking as our training set. Then next 20% data we are taken as our cross validation set. We have not do this thing randomly. We are just taken the first 60% data. Six trainings as training sets, then the next 20% data we have taken as cross validation step, and the last 20% of data we have taken as our test set. We have doing this job. Okay, I think you have understand. So just if you just see, so the past, our past time means 60% of whole data set, the 60% old data set, in the whole data set of 60% old data we have taken as our time. So our in whole data sets 60% data not coming randomly here. Here we are for training purpose we are considering here only old 60% data. Then the next old 60% data we have taken here as cost validation purpose, and the most recent 20% data we are using here for test purpose. So this is actually our advantage for time based splitting. So let's see. Let's see this thing. So in TBS means in time based splitting, so timestamp is a necessary field, is a necessary feature. Is a necessary, is the most necessary feature, timestamp. This is the main thing. But in random splitting, our timestamp is not required. Timestamp is not required. Okay, I think you have understand the main difference of a data set, in which data we are using the time based splitting, and in which data we are using the random splitting. So this is the simple concept, in which data we have timestamp based data in the data set, then we can easily doing the time based splitting job. and in the random splitting, in the data which has no timestamp, then there we have doing the random splitting. It's simple random splitting. So now the questions is, why sir we have required time based splitting? So let's see why actually we have this kind of job we have to do. So let's see why actually this thing is required for us. Suppose let's say I have suppose let's say, so the questions is first, why why we need why we need this thing. Suppose let's say we used the random splitting data. Let's say first we used random splitting. Okay, first let's say, then what we are doing in random splitting? In the random splitting, then we are randomly divided our whole data sets in three parts: the trained data sets, the cross validation data sets, and the test data set. And randomly we have chosen the data 60% from the whole data as training set. Randomly we have chosen the 20% of data as cross validation set, and similarly for test data set we have chosen this thing randomly. We have chosen this thing randomly, and according to this value, means according to this train data value, we are choosing here our nearest neighbor points, and according to this value we are choosing our best k, means optimal k, and according to this test data we are finding the accuracy of our whole data set. Okay, suppose let's take for some time, let's take our accuracy of a model, of such model for random splitting is 93%. Suppose let's take okay, so what happened if we taken, so suppose if we taken here the our accuracy is 93%, then can we actually conclude it our model will be the give same accuracy for the future unseen data? So let's see, why not, actually why not? So I think if we draw some pictures of like that, then it will be clear more all of you. Suppose let's take this is the today, this is today. I have before our data is collected from the previous day, from our today. Suppose this is our today's day stamp. Today's day stamp is this one, and our data is actually collected our data from this timestamp. Suppose let's take this is collected our data dn, and from this data set we are dividing from this data set we are dividing this data set randomly to collect our train data and to collect our test data, as well as to collect our cross validations data. And from train data we are collecting this thing randomly 60%, 20%, and 20%. Okay, randomly we are doing this job. And from training data we have decided our NN, nearest neighbor point. From test data we have from cross validation data we have decided our best k, and from test data we have decided our accuracy. We have seen from this data, but after getting the, suppose we are getting air accuracy is equals to 93%. So okay, our manager says that yes, your accuracy is right, you can satisfy and you can now deploy your model. So according to that, now here actually what we are doing, actually here we are now deploy our model, means our now model is now live in some workplaces. We have live publicly, we are live our model. Then what happen, then after this data, after the 2 days data, means if we got the data suppose tomorrow, then suppose in the future data, means Actually, I want to in future data. So the model, actual model, our give the same accuracy. So it is not. It may not be true. So in these regions, in this after tomorrow, our model may not be give accuracy of our models give approximately 93%. So okay, it's not true. I think our model not give 93% accuracy, but it actually give 92%. Yes, somehow near about 92%. So this thing is actually not true. If we expect this thing, from this model, if our expectation, if we expect this from our model, then this thing actually may not be true. This thing we have see actually in real world. If you just see, just we are just built a model just using previous data, but this model may not accurately doing the same job. The accurately do not give the same accuracy for future data. So in such situations, what I have to do? So in such situations, this random split do not work. In these situations, we have to doing the time based splitting. So let's see let's see why actually this thing happen, why this may not occur. First, let's why this thing happen, then we are doing how to overcome this job. So because with time changes, our humanity is not depend on actually our social psychology, actually our environment, and we cannot predict this chaos. Suppose it will be better if we write this thing. So with time, our patience, or suppose our environment, it will be better. Our environment, our choice, our culture, it's it. This is not we have not handled. This is totally depend on our nature. Okay, so we cannot predict this thing. What will be our future environment? What will be our future choice? What will be our future generations culture? So we cannot predict this thing. Because of this with time changes, we cannot predict. We cannot predict this thing. Okay, so the main problem is, suppose if we cannot predict this thing, so we cannot tell the model that we deploy according to our past data, this maybe give our same accuracy on the future data, because this thing actually change. Actually, data is what? Data is depend on our culture, data is depend on our choice, what we have given, what we have give the review, what we've chosen in the society. That thing is actual data. Okay, when the time changes, our choice, our environment, our everything is choice dramatically, and we cannot predict this thing. This is totally independent on us. Okay, so on these situations, on this, just see this thing visually see this thing visually. I think this, then it will be better. Suppose let's take this is our time axis. Let's take this is our time axis, and we have built this model today. This is our today timestamp. Okay, and we have collected our data from previous 3 months data. We have collected our data 90 days data. So this term will be today minus 90. We have collected data DN from 90 days data, and on this data we have divided this thing in randomly. We have divided, splitting this thing for training data, for test data, And for cross validation data, okay, we are doing this thing 60% for randomly. We are doing this thing. Suppose let's take our train data is green. Suppose let's take our train data is green color, and our test data is red color, and cross validation data is, suppose let's take blue color. Okay, so we have just splitting this thing randomly, so our train data will be lie everywhere. Its probability to lie everywhere on our whole data sets, because we are doing these jobs randomly. And similarly for test data, this also probability lie on this everywhere on our whole data set, everywhere equally likely. Both the things are equally probable. And similarly for cross validation data also, everywhere it is equal probable, because we are doing this job randomly. Okay, so on the basis of that, we also choose our NNN, we also choose our key, we also find our accuracy on this random data. Okay, so our all the data is well distributed everywhere. So when we can predict this thing, when we can predict our model from here, we cannot conclude, we cannot actually conclude, we cannot, it's impossible, actually impossible to conclude correctly. Correct. Impossible to correctly, impossible to conclude correctly, because our data is totally randomly spread it everywhere. So from this, if we not consider this data on our to build our model, so it is totally impossible. So how to now in such situations, how to get rid of? So just drawing the same picture again, this is suppose our time axis, and today we have collected this data. This is our today stamp, and this is 3 months data we have collected, or 90 days data we have collected. So this timestamp will be today minus 90. But in such cases, instead of doing randomly this job, in such cases we are doing such like a we are doing this job like that, like it means we have collecting our we have taken here green color for train data set. We are collecting the data 60% of data from the times. Actually we have this data, we have the timestamp. So for the past old 60% data, we are considered as our training data. So I think this data will be today minus 30, in 60 days data. 60 days data we are collecting as our training data, and today minus 15, this data we have taken means 15 days data. Yeah, this 15 days data we are taking as our cross validation data, and the most recent data we are taking here, the most recent data, most recent we are taken as our test data. I think you have understand this thing. So our training data will be lie on this region, lie on these regions. Not, I have not taken or whole data from everywhere. I am taking the most old data, most old 60% data as an example here. Most old 60% data we have taken as our training data, and most 20% data, next most old 20% data we have taken as our here as our trend as our cross validation data, and the next most recent 20% data we have considered as our test data. So in such situations, so according to this old data, we have decided our NN according to this old data. According to this means this will be 30 minus today minus 30, I think. So according to this old 60% data, we have decided our NN nearest point, and the rest most recent and the next old data and the next old 20% data we have used here as to decided our optimal k. Best k means best k, and it is 20%, and the most recent data we have using here to find the our accuracy. Okay, I think you understand the difference between them. So in previous cases we have considered all the data, our every data is spread everywhere, but in such cases our data is not spread everywhere. We are just split data according to our timestamp. So we have considered our neighbor point from the previous 60% old data. To our old data we have just taken our near point, and the next old data we have considered as to decided our best k, and the most recent data we have taken as our to justify the accuracy. Means if you just see this thing, if means if you just see, you can just analyze this thing another way. If you can consider this thing, if we just deploy our model in the 2 day minus 15, if 2 day minus 15 is, if we deploy our model, if from 2 day minus in this day, so from 2 day minus 15 means from previous 15 day, if we deploy our model, then you can assume that our model accuracy, here the accuracy that we got, actually we have built this model means from previous 15 days, then on this model we can got this accuracy. Suppose let's take we got this accuracy as 91%. Suppose let's take instead of what we have getting here 93% accuracy from the whole data, but here instead of if you using this time based splitting, here we have got this thing as 91% accuracy. But if you just see just see thing really, just if you just visualize this thing in really, then you can see that if you just deploy this model, if you live our model before 15 days, then we can get this accuracy, so using this most recent data sets. So this thing is actually meaningful. If we see that we have got the accuracy 91% data by simple using the most recent data. So this thing, they are, if we take the most recent data from here, so there may be more chance to get the same accuracy, because we have seen this thing from previous 15 data. For previous 15 data we have seen this accuracy 91%. So there will be a more chance. So there will be a more chance to get more chance to get accuracy 91%. We cannot say it will give accurate 90%, but more chance here. Instead of in such cases, here it will be more chance to get the accuracy 91%. Okay, I think you have understand. So if you just conclude this thing, if you just summarize this thing, so what actually we got from this? So we got, if we trained my model 15 days back, if we just simple trained my model 15 days back, and if I tested it on last 15 days data, then what, then we got the accuracy, then my accuracy of our model, then an accuracy of our model is 91%. This means that we have C actually in random based splitting data, from random based splitting data. So this kind of splitting is available only when our times, the features time is available. So whenever time is available, and if the things, or sample the behavior, or sample, you can sample, or our data, changes over time, then only time based splitting is preferable. Then only time based splitting is available, okay, sorry, preferable instead of random splitting. I think this idea is now clear, when, why, and how this is actual work for a unseen data. Okay, so actually this thing happen in natural world. We have see this thing. Data is not depend on ourselves. Data is totally depend on our environment, our psychology, our mentality, in our futures. How we have our, how our futures will come, how we behave to our society. So that's totally these things it yours. We have not predict anything about that. So I think if in a data timestamp is available, then instead of using random splitting, if we using the time based splitting, that will be great for us. This accuracy will be, if this accuracy is low for random splitting, random, if we just find accuracy is random based splitting 93%, or if we finding a accuracy 91% in some time based splitting data, then we always prefer time based splitting, because of this, because the model is always get the most better accuracy in future data if we simply use the time based splitting. So I think this lecture, the motto of this lecture is clear all of you, and why time based splitting we have used, and how, when this thing is preferable. And I think this is simple thing. I have just discussed this thing through an example to clear all of you. So although if you have any problem, please comment below, so I will try to give my best.